Hi, hey Russ here. Welcome back to the shop. Today I want to talk about vacuum manifolds. I also want to talk about vacuum pressure volume. Those are two new terms that you're probably may not have heard of or have limited idea of what they are. Let me show you what they are according to OTB Thinker. So the other term you're going to hear is a run and a home run. And basically a run and a home run is, we're talking about if we're going to have a central vac system in your shop, as opposed to having an individual vacuum on each machine. You run piping and you're going to join them all together. Well, the way everybody does it right now is pretty much you have your dust collector, whether it's a shop vac or a dust collector, it's the same theory, what we're going to be talking about today. Then you have your second stage collection, which collects all the big chips and stuff like that to protect the blower motor and to get most of it collected here so very little gets clogged in the filter in your collector itself. And then from here, you run it. If you take your pipe then from here and run it to a machine, then you have what I would call a home run. It's a run from one point to one point. If you decide that, well, now I'm going to centralize this whole system, and what I'm going to do is I'm just going to run to each of my machines and put a blast gate on each of them. So now you have multiple runs coming off of the whole system. When you had a home run going from here to here only, you need to consider what I call the vacuum pressure volume. Vacuum pressure is in this tube here, running through the steam baffle all the way to the blow motor. That's all on vacuum. So the more pipes you put on it, the more volume of vacuum pressure you have to maintain in your system. That this blow motor is working harder to maintain vacuum in a larger area. And so the larger you make that area, the harder that machine works. And quite frankly, the harder it is that no matter which blast gate you open, the further away you get and the more volume you add, the harder it is to take the debris that's going in there and getting it all the way back into your dust collector. It gets harder and harder as you have more volume. So when they talk about how far away the run is to a particular machine, what makes that have a problem is if you had 6 of them right here and then you had another one right here and you say, well, that's only a 10-foot run from here to there, but you got all this other pipe in here that adds to it, you might as well stick that thing out 40 feet instead. It does affect the system as to how much of this volume that you have in your system. So you want to consider that. Well, this is where a vacuum manifold can come in, and it can be advantageous. Instead of having a gate on each of these, we're going to centrally locate that whole system in a vacuum manifold. Now, first off, everybody will tell you that, oh yeah, you put the blast gate right on the machine. It's so much easier. It is only if you remember close that darn gate when you're done. You forget to do that, then you're going to be walking around trying to figure out which damn gate is open so that you can get your machine to suck real good that you're trying to work with right now. So it can be a disadvantage. Especially when you get old. That's another story. But it can be a disadvantage to have those blast gates at all these different locations. If I was to take this same system now, and instead of running this all the way out, putting blast gates on the end of everything, let's take and add a manifold. And we're going to put a run to there, a run to here, run to there, and a run to here. And we're going to put our blast gates all right here. And there are two things that we've accomplished by doing that. For one thing, we've centralized all our blast gates so that we know which one's open, which one's not open instantly by looking at it. And the other thing you've done is dropped dramatically your vacuum pressure volume. Because now, if I open this blast gate, it's actually a home run from here up to there. That's the only vacuum there is. All of this is still at an atmosphere pressure. If I close this one, I open this one, that's a home run. So you've actually increased dramatically. And then you say, well, you lose it in the box. Not if you do your box aerodynamically. And the way to do that is, that's another video. There is something you can do to increase that, but I found that what you gain on volume, what you lose here, I think, is less. And again, all your blast gates are in one point, so you can always open and shut your blast gate when you're ready to use a piece of equipment. That's where you put it. And then you say, well, I don't want to have to walk over in the corner of the shop every time. Well, that's not where you have to have that. You can actually have this anywhere you want. Since it's always going to be a home run, this area here is the only thing you're changing when you move this out to make this into a shop, into a manifold. Instead, if I take this run and I take all of this, now I move it across the shop into the center so it's equal distance to all my machines, like so, and I run this there, what's happened? Well, I can tell you right now, the volume, the vacuum pressure volume of using any one of those machines, again, your blast gates are still right here. Okay? I didn't decrease my vacuum volume at all in that. I still run from here and up to there. That's pretty much the same distance as if when it was over here and I run it to here and then run it way over to there. So this becomes pretty close to the same amount of vacuum volume that you have even if you had this over here by your vacuum. So you can actually put this anywhere you want in the shop and then run your home run to here. And then here is where you would then shoot off to all your ones, and that would be centrally located so that you can open and shut all your valves instantly, and you know which ones you have open and closed. So a vacuum manifold in your system doesn't degrade your system near as much as it can really help you if you're designing the kind of system that is a central vacuum system, whether it's dust collection or shop vac. It doesn't really matter. This same vacuum manifold setup is actually a good idea to figure out how to use it and where is a good place to put that in relationship to where all of these things are. So this is just a food for thought. I'm trying to help you think outside the box about how to design your own shop vac system as you evolve in your workshop. And this is something that I used to do actually, but I've actually since then, have decentralized my vacuum systems. I have a shop vac, I have a dust collector here for my bandsaw and my planer on the cart, so it's all self-contained. I have a dust collector over there that will work, move between each of those machines over there. And my shop vac, I have one right over my legacy workstation. I have a central vac that I use that's in the center of the room to use that one if that's what I want to use. So I actually prefer putting vacuum directly on some of the machines. My miter saw is a good example. I've got its own central vac. It's got its own shop vac on there, and I've shown that to you early last year too, with a theme baffle and a very small shop vac on that system. And it goes on and off every time I pull the trigger on that miter saw, and that makes it much easier to use that machine and still have the dust collection working every time I use it. So that is very passive, and that's why I decentralized it from the regular system. So you can do it however you want, but if you're going to use a central system, you want to think about using a vacuum manifold in that system too. And think about your vacuum pressure volume and how you can change where the location of all these pieces of equipment are and where you would put your vacuum manifold in relationship to the volume that you would be using in the whole system. So one more thing I want to talk about real quick here before I let you go, even though I'm sure that you're probably saying, what? No wonder you call that rambling, Russ. But actually, there is one more thing I want to discuss, and that's the theme baffle itself. I honestly do not know the answer to this. If somebody out there knows this, great. I'm just thinking outside the box. But what if I take this theme baffle off of there and I move that theme baffle to right here so that this runs here, and then this runs here. And I bring the theme baffle here. Will it do a better job of collecting, being closer to where your source of your material is coming in? Or will this work better when it's back here and you're dragging that material further? It's just a food for thought. I would like to take and try this one time. I may try this on my central, one of my shop vacs, and move the theme baffle, which is right next to the shop vac now, and move it here to the center up above me, and see if that makes a difference on how well it's collecting everything and how well it's drawing everything and getting it up into the baffle. Just food for thought. I don't know. Like I said, I don't even know if it makes any difference. So I thought it was very interesting, and I think this is an interesting concept to think about. If anybody knows the answer already, I'd love to know, because I haven't seen anything out there that talks about where you actually place these things in relationship to your vacuum pressure volume and your whether or not you have all these different runs and what a home run is, and where exactly is the best place to put this stuff. So anyway, whatever you think, I really appreciate you taking the time to listen to Rambling Russ. Hopefully this will strike up some conversation, so maybe we can all figure this out together. And like I said, if you have any information, leave it in the comments. I'll go check it out, because I'd like to learn more about some of this stuff. Some of it I've figured out, some of it I don't know the answer to. So let's see if we can figure it out. I hope you liked this video. I hope you learned something. If you did like it, please say so. If you have any comments, leave them below. Most importantly, though, come back again, because I'm nowhere near done. Thanks for stopping by, and we'll see you again very soon.